the infinite sequence and series, and we have taken, let us today also we recall thing that the first we have taken what, let us recall all these things. So what is infinite series? So you are having say this kind of things. Like series AN, that means there are infinitely many terms, and if you add all these terms, this is infinite series. And we ask the question whether the sum exists or not. Okay, does the sum of infinite series possible? If the sum is possible, we can say that the series is convergent. The sum is possible, we say that the series is convergent. And if the sum is not possible, we say that the series is divergent. And if the sum possible, there are two kinds of series. One is a telescoping series and another is geometric series, where we can find out the exact sum also. In two types of series, one is telescoping and another is geometric series. Okay. Now, what we did here, this is the definition of convergence of a series. So we first take the sequence of partial sums. What is that? So S1 is A1, then S2 sum of the first two terms, S3 sum of the first three terms, Sn sum of the first n terms, Sn plus 1 sum of the first n plus 1 terms, and so on. So now you are having S1, S2, S3, and so on, Sn as a sequence. And if this sequence is convergent, and say suppose if it is converges to L, that means limit n tends to infinity, Sn equal to L. Then this is the definition of convergent series, that then the series sum of the series is also L. In that case, the series is convergent. This is the definition of the convergent of a series. This is the definition of convergent of a series. It is difficult for all kinds of series, but only say telescoping series, this definition we can apply easily. So we took one example like this, and we can arrange the terms in this way so that we can find out Sn properly. If you can find out Sn easily, then you can apply these things. So here we could in a position to find out Sn easily. We can find out its limit, and so the sum of this series is also the value of the limit. And we have taken one more example also, and we may take one more example even today also, so that it's like that you are having the revision kind of things. So let us take one more example today also. Okay. Yeah. So let us have one more example. Say. Okay. So let us take one more example of this telescoping series and then we can solve it. So test the convergence and if convergent, find the sum. If it is convergent, then find the sum. Okay. We can have like this. Sigma n equal to 1 to infinity. You can have like 40n okay, simple example if I want, then like this 6 upon 2n minus 1 2n plus 1. Okay, so this is series an. So an is 6 upon 2n minus 1 2n plus 1. You can arrange in some of the way like something say 2n minus 1 2n plus 1. Simplify, what is that? 2n cancel. So can I write like this? Check it. Yes or no?
Yes, sir.
Okay, fine. So so now we can have easily S1. What is S1? 3 into 1 minus 1 by 3. Agree? What is S2? S2
2 by 5.
2 by, I want in this way.
Three into 1/3 minus 1/5.
Yeah, so it is like this 3 into 1 minus 1 by 3 plus S2 means what?
3 minus 1/5.
A1 plus A2. These are AN. Okay, then 1 by 3 minus 1 by 5 like this. This is our S2 and so on. Sn 3 into Sn is what? A1 plus A2 plus and so on An. That is nothing but the Sn. Okay, Sn is A1 plus A2 plus and so on An. This is Sn. And so what is A1? A2, An, everywhere you are having 3 outside. So this is 1 minus 1 by 3. This is A1. A2, 3 already taken outside. 1 by 3 minus 1 by 5. Isn't it? A2. A3 1 by 5 minus 1 by 7 and so on. An 1 upon 2n minus 1 minus 1 upon 2n plus 1. Agree everyone?
Yes, sir.
Okay. And so what you are having 3 into this 1 by 3 cancel, 1 by 5 cancel, 1 by 7 also cancel, 1 upon 2n minus 1 also cancel with the previous term. So this 1 remains and this also remains. So it is 1 minus 1 upon 2n plus 1. This is our Sn. Now what is limit n tends to infinity Sn? Limit n tends to infinity 3 into 1 minus 1 upon 2n plus 1. What is this one? Limit 3 into 1 minus 0. And so that is 3. And so that sequence is convergent. And therefore the given series is also convergent. So series n equal to 1 to infinity. This is also convergent. Okay. And sum is what? Sum of all the infinitely many terms is 3. Okay, everyone agree? Understood?
Yes, sir.
Yes, sir.
Write down. Write down then. Okay, everyone.
Yes, sir.
Yes, sir.
Okay. Okay. So next, let us have same means check for convergence and find sum. These are all telescoping series. So you are having like this. Four upon 4n minus 3, 4n plus 1. And second, you can have sigma n equal to 1 to infinity 1 upon root n minus 1 upon root n plus 1. These are all easy examples. This is directly given. Sigma n equal to 1 to infinity 1 upon 2 power 1 by n minus 1 upon 2 power 1 upon n plus 1. Sigma n equal to 1 to infinity 1 upon log of n plus 2 minus 1 upon log of n plus 1. Sigma n equal to 1 to infinity tan inverse n minus tan inverse n plus 1. These are all similar example. All are telescoping series. If you want, we can solve one example. Otherwise, you can able to solve it all the example. It's fine for me. Do you want me to solve one example here again?
Sir, the first one.
મૂરખ કહેવાય તો ફર્સ્ટ વન કહું તો કેમ?
First
ચાલો.
one, sir. First one to easy, sir.
If you say first one, and I am saying મૂરખ કહેવાય કેમ? કારણ કે ઓલરેડી મેં એ જ સોલ્વ કરાવ્યો છે. આ પણ સોલ્વ કરાવ્યો છે. અગાઉ ફર્સ્ટ પણ એ જ સોલ્વ કરાવ્યો એવો જ છે. So it's a foolish choice. Choice is very important in the life. Okay, even when you are getting married, choice is very important. Even આ પણ એવો જ છે. So why it is first one? Okay, then what is another one choice?
Sir,
Don't say
third.
that first one કહ્યું સરે ના પાડી એટલે સરને નથી આવડતો.
હા સર
Third one.
હા એટલે પાછી તમે MC ગ્રુપના પ્રાઇવેટ ચેટ ગ્રુપમાં એવું ના લખતા એમ.
Sir, first તો easy જ હતો. Third કા fifth કરાવો ને બેમાંથી.
થર્ડ કા પછી ફિફ્થ કરો.
થર્ડ કે ફિફ્થ?
Third one.
Okay. Okay. All are easy. Let us see. Let us take third one. So this is sigma n equal to 1 to infinity 1 upon 2 power 1 by n minus 1 upon 2 power 1 upon n plus 1. Okay, this is our an, sigma an. So an is 1 upon 2 power 1 by n minus 1 upon 2 power 1 upon n plus 1. Let us directly write Sn. What is Sn? A1 plus A2 plus A3 and so on. An. What is A1?
One upon two minus 1 upon 2 power 1 by 2.
Okay. What is A2? Is it okay?
Yes, sir.
Okay. A3 say suppose. And so on. An is 1 upon 2 power 1 by n minus 1 upon 2 power 1 upon n plus 1. If you add all the terms, what you are having now?
1 by 2 minus 1 by 2 power 1 by n plus 1.
Everyone okay or no? Everyone understood or no?
Yes, sir.
Yes, sir.
Understood. Okay. Now, so this is our Sn. So then you can find out limit n tends to infinity Sn. So limit n tends to infinity.
It
1 by 2 minus 1 upon 2 power 1 upon n plus 1. So answer is 1 by 2 minus 1 upon 2 power
by
0.
0.
Yes or no? Because when limit n tends to infinity, 1 upon n plus 1 tends to 0. So 2 power 0. What is 2 power 0?
1.
So what is that limit?
1 by 2.
Minus 1 by 2. Okay. So that means this sequence of partial sum convergent, and therefore by definition this series is convergent. And its sum is what? Minus 1 by 2. આ series નો sum છે minus 1 by 2. બોલો સમજ પડી બધાને?
Yes, sir.
Yes, sir.
Okay. So you can write this, or if you have written, you can proceed further. લખી લીધું બધાએ?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So this is about the telescoping series. Okay, this is about the telescoping series. આ બધા all these examples are so easy. Okay, directly આ તો an જ મળી જાય, એટલે sn મળી જાય. આમાં tan inverse infinity આવશે. Tan inverse infinity when you take the limit, and you know tan inverse infinity is pi by 2. Isn't it? So you can get the answer here also, no problem. So that was the first kind of series that we have, and that is nothing but the telescoping series. Okay, fine. Even let us have 1 or 2 more examples also. I can write. Let's write same telescoping series. Okay, I'm just writing sigma n equal to 1 to infinity 40n upon 2n minus 1 square 2n plus 1 square. Sigma n equal to 1 to infinity 2n plus 1 n square n plus 1 square. Yeah. Okay. Anyone, if you want to solve these two example, I would like to solve one example. બેમાંથી ગમે તે.
First one.
Okay. Anyone we can solve, you will definitely have the okay. First one. So this is series n equal to 1 to infinity 40n 2n minus 1 square 2n plus 1 square. This is our an. So an is 40n 2n minus 1 square 2n plus 1 square. Can I write this as 1 upon, let us try, 2n minus 1 square minus 2n plus 1 square, and let us simplify so that you are having 2n plus 1 square minus 2n minus 1 square like this. And if you simplify, the first term and the third term will be getting cancelled. Middle term you are having here 4n, and here also minus 4n, but minus sign is there, so 8n. Agree or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Understood now this part?
Yes, sir.
Okay. Fine. Okay. So then our work is over. This is very easy now. An is in this way. So now what is Sn? A1 plus A2 plus A3 and so on An. Every time phi is there. What is A1? 2 minus 1. 1 and it's square, so it is 1. 2 plus 1, 3. So minus 1 upon 3 square. Yes or no? A1 is plus. What is A2? 5 already taken away outside. 2 to the 4 minus 1. So 1 upon 3 square. 2 to the 4 plus 1. 1 upon 5 square. A3. 3 to the 6 minus 1. 1 over 5 square. Minus 1 upon 7 square. And so on. Last. An. 1 upon 2n minus 1 square. Minus 1 upon 2n plus 1 square. Agree or no?
Yes, sir.
Yes, sir.
And
Yes,
what
sir.
it remains is 1 minus 1 upon 2n plus 1 square. Because this to cancel, this to cancel, this cancel with the this one, this cancel with the previous one. So remaining is 1 and this. And so limit n tends to infinity. Sn is equal to limit n tends to infinity phi 1 minus 1 upon 2n plus 1 square. So this is phi into 1 minus 0 because limit n tends to infinity 1 upon 2n plus 1 square is 0. And so this is nothing but phi. So we get limit n, so convergent. And therefore, by definition, series n equal to 1 to infinity 40n over 2n minus 1 square 2n plus 1 square, and that complete sum is 5, and so it is convergent. Got it, everyone?
Yes, sir.
So same way you can try to solve this example also. This one, isn't it? Okay. So these are the examples related to telescoping series. Then what was the next thing that we did? See, was the geometric series. This one. Geometric series. Okay. So it is of this like, and if this one is there. So this is a geometric series, and that series is convergent. If n only the ratio, and take the modulus, if suppose a negative ratio, then so that modulus of the ratio is less than 1, then the series is convergent. And the sum is also there, first term upon 1 minus the ratio. And yesterday we have taken some examples of the geometric series. Okay, like this. So we find A and we find R, then you find modulus of R if it is less than 1. convergent, and you can find out the sum. If it is not less than 1, then you can directly declare that the given series is divergent. That means the sum is not possible. Okay, so we can have some examples of geometric series also. Okay, like so this one summation. Okay, like I can write some examples, or I can send the picture in your group, and you decide which example you want to solve. Okay, so I would like to send the picture, and you can just see the things. Okay, so you can see that 7 to 14 in your, I have sent that picture, and whatever you want, let us have, we can try to solve these examples. All are geometric series. Okay, let us have 2 examples to be solved. Which example you want to solve? Chalo, decide. Don't worry, you can decide. If you decide not properly, I will say again decide. Okay.
સર -1 હોય તો એને આપણે બે
Number.
ભાગ કરવું પડે ને.
નંબર કયો નંબર છે એક્ઝામ્પલ? -1
ઇન્ફિનિટી.
-1 એવું ના હોય ક્યારેય.
10 નંબર.
બે ભાગ ના હોય. બે ભાગ કેવી રીતે? મેં ગઈકાલે કરાવે છે એક્ઝામ્પલ. તમે અત્યારે કયો નંબર જોઈએ છે બોલો પહેલા, and then you get
સર
the answer.
11.
એમાંનો
11.
11 you want. Okay, then 11 કરો, એના કરતા તમારે ચોઈસ કઈ આપવી જોઈએ? 13 આપવી જોઈએ. અને તમારે એક્ઝામમાં ધ્યાન રાખવાનું છે n ક્યાંથી શરૂ થાય છે. n 0 થી છે, 1 થી છે, તો ફર્સ્ટ ટર્મ તમારું બદલાઈ જશે. બરાબર છે? So that you need to check. Here n equal to 0 to infinity. Always you need to check n begin from where. And 1/2 power n plus -1 power n on 5 power n. Geometric series is like this: a r power n. n equal to 1 હોય તો, અથવા r power n minus 1 પણ હોય, 0 2 પણ હોઈ શકે, like this. આ બધી geometric series. 1 થી હોય તો પણ r power n થઈ શકે. આ પણ geometric series જ થઈ. This is also geometric series. Okay, so this is geometric series, this is also geometric series, this is also geometric series. Fine. પણ બંનેમાં ફર્સ્ટ ટર્મ, ત્રણેયમાં ફર્સ્ટ ટર્મ બદલાઈ જાય છે. ઓકે, that you need to take care. Okay, fine. So you can write this way. Can I write in this way? Yes or no?
Yes, sir.
Okay. Now see, we are having 2 geometric series. This is also a geometric series. This is also a geometric series. So there are two geometric series. What is the first term here? આ એક્ઝામમાં આવું બધું લખી શકાય, આવું જ કરી શકાય, બરાબર? What is first term here?
1.
1.
1. Because you are taking n equal to 0. ધ્યાન રાખજો. If I take n equal to 1, the first term is 1/2. એટલે આન્સર સમ નો આન્સર બદલાઈ જાય. What is the first term here?
1.
Ha. 1. What is r here?
1/2.
1/2. What is r here? Minus 1/5. And in both the case, modulus r, in this case 1/2, in this case 1/5 is less than 1. So both the series convergent, and therefore both the series convergent, and therefore the whole series is convergent. So this series is convergent. Now if you want to find out sum, what is the sum? A upon 1 minus r. So the sum is like here 1 upon 1 minus 1/2 plus 1 upon 1 minus 1/5. And then you can add this and find out the sum is your answer, sum. Okay, understood everyone?
Yes,
Yes,
sir.
sir.
Okay, so do that, find out the sum, and then you can solve yourself any one example you want, like 12 you solve and you give me the answer. Okay, hello?
Yes, sir. Yes.
Okay, you can just solve the 12 and you can give the answer.
સર 12 નો આન્સર આવી ગયો. ચેક કરી દેશો?
Hello?
હા સર.
Yeah. બીજા solve કરો, હું coming back in 2-3 minutes. Okay.
જેને આન્સર આવે કેજો.
17/2. 17/2.
17/2. હા ડન.
1.
13th નો answer 7/6 ને. ના આવ્યો એ કેજો.
ટ્વેલ્વ નો આન્સર 3/2.
17/2.
12
17 17/2 છે.
13th માં શું આવ્યું કોઈને? આવ્યું કઈ?
17/6.
17/6 13 માં. 12 માં એક ટર્મ કન્વર્જન્ટ નહીં થતું.
Okay. Hello. Okay. Hello.
Yes, sir.
Yes, sir.
Yeah. So yeah. So બધાના આન્સર આવી ગયા છે.
Yes, sir.
Okay. I think આવો આપણે ગઈકાલે કર્યો હતો ને.
Yes, sir.
હા. આજ આવ્યો હતો ને આજ હતો ને કઈક એમ.
આ નતો પણ આવો હતો.
આવો હતો. Okay. Is it okay? 17 by 6.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. બાકીના કોઈ એક્ઝામ્પલમાં કોઈ પ્રોબ્લેમ આવે 7 to 14 માં? નો પ્રોબ્લેમ બરાબર છે ને? લાઈક 10 માં 10 કરો તો શું કરો તમે? સિરીઝ n equal to 0 to infinity. આ ખાસ ધ્યાન રાખજો એક્ઝામમાં 0 છે કે 1 છે. That you need to check. -1 power n 5 upon 4 power n. So basically you should write like this. Pi series n equal to 0 to infinity -1 by 4 power n. You understand? એટલે 5 તો આમ જ રાખવાનું. And this is geometric series. A is 1 because n begin from 0. And R is -1 by 4. So sum is A upon 1 minus R. Like this. Simplify karo. That is your answer. કેટલો આન્સર આવે છે?
Four.
4 આવે છે ને? હા.
Four.
Okay.
Four.
Okay. Okay. Done? Everyone?
Yes, sir.
Okay. So some examples I can write here. You can try at home. થોડાક લખું છું. n equal to 0 to infinity 1 upon root 2 power n. N equal to 0 to infinity root 2 power n. See, n 0 છે એટલે અહીંયા r 1 upon root 2 છે. અહીંયા r કેટલા છે? Here r is root 2. But what about that? It is greater than 1. So this geometric series but divergent. Yes or no?
Yes, sir.
અહીંયા પણ ધ્યાન રાખવાનું છે. Modulus r is less than 1. That's why it is convergent. Geometric series હોય એટલે convergent એવું ના હોય. If it is r less than 1, modulus r less than 1, only then convergent. આ convergent છે. R is 1 by root 2. Okay, no problem about that. Same way, some examples are there. N equal to 1 to infinity -1 power n plus 1 3 upon 2 power n. So basically this is also geometric series. How to write down this? Can you write in this way? Series n equal to 1 to infinity -1 into -1 power n 3 upon 2 power n. Agree or no?
Yes, sir.
Yes, sir.
And then you can write -3 series n equal to 1 to infinity -1 by 2 power n.
Yes.
Okay, and then you can do this. Understood?
Yes, sir.
Yes, sir.
Okay. So those are the some of the kind of examples that you are having to have geometric series, like series n equal to 0 to infinity e upon pi power n. There is also one more example. Series n equal to 0 to infinity e power n pi upon pi power n. So see, this A is 1 geometric series. What is R? E by pi. E means 2.7 something, pi is 3.14. Even you are having calculator also. So you can see that modulus R is less than 1. So convergent. And sum is A upon 1 minus R. So pi upon pi minus E. This is the sum. Same way here. Here you can write in this way. N is 0 to infinity. This is e power pi upon pi power e and power n. Agree? Yes or no? So
Yes.
this is again a geometric series. And first term is 1. And R is e power pi upon pi power e. Now you should use the calculator. You should use the calculator and find out what is the value of e power pi upon pi power e.
Sir, greater than 1.
Greater than 1. It is easy, okay? It is easy to find e power pi upon pi power e. E che, you are having e's on your okay. E તમારા પાસે હશે E. એટલે તમે E જ રાખજો હા 2.7 ના લખ 2.7 ના લખતા.
Okay, sir.
ઓકે કેલ્ક્યુલેટરમાં E છે જ. તો E અને પાઈ પણ કેલ્ક્યુલેટરનો જ યુઝ કરજો. E પાવર પાઈ upon pi power e. So is it greater than 1? If it is greater than 1, then you can write divergence. Okay, everyone?
Yes, sir.
Yeah, if it is greater than 1, we can write divergence. Okay? Fine. So these are the kind of examples that you are having. And